All right, so we want some help on graphing inequalities. First of all, we want to solve this for y. We want it to look like this, y equals 3x minus 7 or something like that, except it might be less than or equal to, or greater than or equal to, because that's the point. It's an inequality, not an equality. All right, so this one, if I were going to solve it, I'd start by subtracting 2x from both sides, and then I'll have 3y is less than or equal to negative 2x plus 9. Now I'm going to divide by 3. I'm all the parts, dividing by 3, dividing by 3, dividing by 3. And now I have y is less than or equal to negative 2/3 x plus 9 divided by 3 is 3. There we go. Now, if I can graph that with a nice straight line, I'm going to start at the y-intercept, which is 3, which is right here. That's the x-intercept, sorry. Y-intercept, 3. And then I'm going to use my slope. This part here is the rise. This part here is the run. So I'm going to rise negative 2, and I'm going to run 3. That's the definition of slope, is rise over run. So I'm going to rise negative 2, that means drop down 2. And then I'm going to run 3, that means go 3 this way. And then I put a dot here. And I go down 2 and over 3, and I put a dot there. Down 2, over 3. There we go. And now, this is an important part. That should either be a dotted or a solid line that I just drew there, based on whether or not the symbol they give you has an equal sign in it. Do you notice that I had a problem that had an equal sign in it? Therefore, I can use a solid line. If I just had said less than, then I would have to use a dotted line. All right, last thing is, this less than or equal to, since it says less than, if you get it solved for y like this, that's part of the beauties of solving for y, is now I can trust that if it says less than, I shade underneath it. If it said greater than, I would shade above it. So this one says less than, so I'm going to shade underneath it. What it really means is any of the points here, like let's say 0, 0, or 2, negative 1, any of those points that are down in that area will work when you plug them into this equation, and they will make a true statement. All right, that's what we're doing, is finding that all the points that are underneath this line work, and all the points that are on the other side of the line don't work. And all the points that are exactly on the line also work because it says or equal to. All right, one last thought. This is a really common mistake people make. If during the course of solving your equation you ever multiply or divide by a negative, you have to switch the sign around to the other way. So like, for example, if I had y 2 minus y is less than or equal to 3x plus 5. Now I'm going to subtract 2 from both sides. Negative y is less than or equal to 3x, and 5 minus 2 is 3. Now I divide by a negative. If I divide by negative 1 here, I'm going to change all the signs. Negative y becomes positive y. This becomes negative 3x, and this becomes negative 3. And if I divided by negative 1 here to make that happen, that's what I did. Divide by negative 1, divide by negative 1, divide by negative 1. Then the sign has to switch to greater than or equal to. So y is greater than or equal to. And that will, of course, affect which way you shade it. So now, on this problem, I would shade, since it says greater than, I would shade above the line that I drew. All right, that's all I got for you.